Tonight in philosophy, which makes me mildly uncomfortable to think about, the problem of induction and the 𝘴𝘰𝘮𝘦𝘣𝘰𝘥𝘺 paradox. I was first introduced to the problem of induction as a snot-nosed college freshman in Philosophy 101. The first example they asked us to consider was, you sit on your chair and every day it supports your weight. Eventually, you might find that you sit in a chair and it's been broken or sabotaged in some way, and it will collapse beneath your weight. Now, you trust that your chair is going to support you because it always has in the past, and that's inductive reasoning, reasoning based on past experience. In the case of the broken chair, it was not reliable. We use inductive reasoning because it's pretty good most of the time. We trust it because it's always worked in the past. We trust inductive reasoning because inductive reasoning tells us to. This is essentially circular, and circular reasoning is no reasoning at all. Now consider this. All of science is based on induction, a pattern of past events to establish predictions for the future. The way weather works, the way space works, the way physics interactions work. Everything we do with science, we do with induction. So the problem of induction is a problem with science. We're doing the best we can, but you can't ever know anything 100% for sure. Somewhere way out in space, physics might work completely differently. We'd have no way of knowing from where we're sitting. This is why it's important to trust science, but with a bit of skepticism. If you trust science blindly, if you trust it zealously, if you treat it like a religion, it's not science anymore, it's scientism. Which leads to a whole slew of other problems that I'm not going to get into in this video. Now you might be thinking, if science is valuable, can we retreat to the perfect axioms of math? If the real world, the universe, the applied mathematics that is science can't be trusted, surely mathematics itself, pristine and pure on the perfectly flat surfaces and the perfectly squared edges, and surely mathematics is fine? And the answer is no. So what is the 𝘴𝘰𝘮𝘦𝘣𝘰𝘥𝘺 paradox? What is the problem with set theory? All of our math, addition, division, subtraction, multiplication, all the higher stuff too, everything that comes about from those is sets. If you add 2 plus 2 equals 4, you've taken a set of two objects and another set of two objects and unified them into a single set of 4 objects. The way these sets function needs to be consistent, because if it's not, 2 plus 2 might not equal 4 anymore. Let's take, for example, a set of all teacups. This set does not contain itself, obviously. The set is not a teacup. Let's take a set of all non-teacups. This set does contain itself because it is not itself a teacup. Here's where things get wacky. Imagine a set of all sets that does not contain themselves. So for example, our first set, teacups, would be in this set. Our second set, non-teacups, would not be in this set. Does this set contain itself? If it does, then it's a set that contains itself and it shouldn't be in the set. If it doesn't, then it's a set that does not contain itself and it should be in the set. There's no right answer here. They're both wrong answers, and that's a paradox. It's a crack in the very foundation of mathematics as we know it. There have been a number of solutions proposed for this, but I've never found any of them satisfying, and neither has the philosophical or mathematical community at large, as far as I can tell from the internet. Between the problem with science and the problems with math, I was left to come up with my own truth so that I could feel a little bit better in my day-to-day life. I casually formulated what I call the fragility axiom, which is any logical structure will break if you think about it too hard, including the fragility axiom. Does the fragility axiom break if you think too hard about it? Well, if it does, then there you go, it's broken. If it doesn't, then it disproves itself. So essentially, I live my life thinking about things, but not thinking too hard if I can help it.